Hello. Today we're going to be talking about proportional parts. And what I have is a triangle ABC, and I've drawn in segment DE so that it is parallel to segment AC. And what I want to do is show that by drawing in that parallel line, it slices segment AB and CB proportionally. So before we get into that, what I want to do is talk about how, because of the parallelism, we know a handful of things about these two triangles that we have here. We know that angle A and angle D are going to be congruent because angle A and angle D are corresponding angles made by parallel lines. And so that means we have congruent angles. That means the same thing about angle C and angle E. They must be congruent for the same reason. Meanwhile, angle B is congruent because angle B is congruent to itself. It's the same angle in both of our two triangles. So what we know that triangle ABC is similar to triangle DBE. And the reason here is, well, we know that all the angles are the same, and so we call that angle similarity. Now, knowing that about these two triangles, that means we know that the sides are proportional. And so, in my small triangle, the length from B to D is x over, I'll use black for that, over the length from B to C in the small triangle is m. Equals. In the big triangle, the length from B to A, well, this length right here being x, and then we need y more put onto that to get the total length, so that whole thing is x plus y. So this is an x plus y over from B onto C. The length from B to E is m, and then we need n more to get our way to C, so that length is m plus n. That whole length is m plus n. Now, knowing what we know about these figures, we're allowed to do our cross multiplication. So I'm going to take the x and multiply it by m plus n. So x times m plus n equals, and I'll do the same thing. I can take my m times x plus y. And to go a little further here, I'm allowed to distribute, so I'm going to go ahead and do that. So I'll take the x times both parts, x times m, plus x times n, equals, then I'll do the same thing with my m's. I'll take the m times both parts, so m times x plus m times y. And what we actually have here, xm and mx, since multiplication is commutative, it can happen in any order, they're the same thing. So if I subtract xm on both sides, these are going to cancel themselves out. And so we know that xn is the same as my. Okay, and what I also want to show you then, in these two figures, we knew that from B to D was x, and from B to E was m, and that was equal to going from D to A was y, going from E to C was n. And so if these are truly proportional, well, when I cross multiply, I should get a true statement. So I'll take x times n first, and then I'll take m times y, and we get the statement xn equals my, which is indeed a true statement based on what we just learned over there. So what this means is we are allowed to do a proportion with parts of a triangle and not even the whole side length, right? Y was part of a triangle, n was part of a triangle, it wasn't even the whole side length of AB or CB. So let's put this to use. I have in this triangle, again, ED is parallel to CA, and we want to find x. So based on what we just talked about, I'm allowed to say that x over 5, because that's the right side, x and 5 are getting compared, would be the same as 14 over 6. And then to solve for x, we do our cross multiplication. 6 times x, and then 5 times 14 is 70. And to get x alone, we divide by 6. So x would be, I can take a 2 out of both 70 and 6. That leaves me with 35 over 3. Or rather, that is, let's see, 11 and 2/3. So either way, we wanted to write that. And so that's how we would find x. For now, we are done.